Hey everyone. So in this lesson we're going to continue with highest common factor, or HCF, and we're just going to be working on finding the highest common factor with a few more examples. So before we were working with groups of two numbers, it was basically pairs of numbers, and now we're going to move on to working with slightly larger numbers, and we're going to do it with groups of three. Alright, so in this one we're going to be talking mostly about just HCF. If we happen to have time at the end, I may go back to LCM, but most probably we're just going to be doing HCF. And if you remember from the end of the last lesson, we sort of threw out that lists method, where if you had a number like, I don't know, if you're trying to find the HCF of two numbers and one of the numbers is like, I don't know, let's say 82, then you're going to be here for a little while trying to make sure you've covered your bases with how many different ways there are to get to 82. There might only be a few ways, but you'll be sitting there racking your brain for so long to make sure that you didn't miss anything that it doesn't end up being the most practical system for us to use. So we're not going to do that listing thing where we just list out, oh, 1 times 82 and 2 times 41. There might not actually be that many ways to get there, but you'll be sitting there for a long time just going through it and trying to make sure that you have all of the numbers. So in the examples that we're going to be dealing with, there are plenty of ways to get to some of the numbers that we're going to be working with, so we're just going to ignore that list method, and we're just going to focus on prime factorization, which was method 1, and that division thing that's similar to the thing we did for LCM, but remember with LCM it would have been like something, we'd have them like that and we'd keep them all together. For HCF you'd sort of split them up. You'd split them up like that and then do each one separately. So this is not our first example, I'm just showing you the difference. This over here is what we would do for LCM, this over here is what we do for HCF. So notice that there is a difference there. It's a similar process, and for prime factorization we build the factor trees for both of them, but once again there's a difference with what you do with them at the end. So that's why it's important to make sure you understand, are we looking for multiples, are we looking for bigger numbers, or are we looking for factors, smaller numbers? So I believe, if I remember correctly from my initial plan for the school year, that this was going to be the last video of practice problems before a brief test review. So if I do go back to the test review, then maybe I'll come up with a couple of examples of some groups of numbers that we can find the LCM and the HCF of, just so you can see the difference in the process and then the difference in those answers as well. So without further ado, we're going to try and get through 3 different examples, so like 3 groups of numbers, and we're going to solve them both ways. We're going to solve them using prime factorization and using that division method. So we'll try and go slow for the first one, and then we'll pick up the pace for the 2 after that. So the first one, I'm going to get rid of that up there. I'm going to say HCF of, and we're going to try and find the highest common factor for the following group of numbers. So the first one is going to be 45, the second one is going to be 75, and the third one is going to be 210. Alright, so we're going to try and find this HCF right here. So if we do it with prime factorization, I'm just making this little note of PF for prime factorization so that you guys can remember the name of the one that we're doing. So for that we're going to start by listing those 3 numbers, and we're going to try and build their factor trees. So we got our 45, we got our 75, and we got our 210. So if we start with this 45, we want to break this up into 2 prime numbers, and we want to break this up into 1 prime number and then something else, right? So 45 isn't going to be divisible by 2, so that's a problem. Right there, we can't divide this by 2, but we can divide it by 3. So if you wanted to check that, then you could go and you could do 4 plus 5, and you get that that's 9. 9 is divisible by 3, therefore this number in its entirety is also divisible by 3. So we put a 3 here, and then we ask ourselves, 3 times what number is going to give us 45? And we get that 3 times 15 is going to give us 45. Right, then moving on to the next one, 3 is prime, so we don't have to worry about that. This 15 we can break down into another 3 times 5, right? This isn't divisible by 2, so we throw that out. The next prime number that we could use is 3, and 3 times 5 would give us 15. We can also bring this 3 down, so we have 3 times 5 is 45. And all of those are prime, so we're done. So that's all of the prime factors that when you multiply them together, you'll get 45. And you can check that, right? You get 5 times 3 is 15, times 3 is 45, or if you go the other way, 3 times 3 is 9, and 9 times 5 is 45. So we're good there. Now for 75, it's going to be a similar idea, but once again, it's not an even number, so we can't divide this by 2. But if you go and you check, this can be divided by 3. So we're going to have 3 times some number equals 75. And what you get is that this is actually going to give 3 times 25. It's going to give us 75. So that's what we get there. Now 3 is prime, so we don't have to worry about that. But this 25 is most decidedly not prime. And so for 25, we can break that down. It's not divisible by 2, so that can't work. It's not divisible by 3, that can't work. 4 is not a prime number, so we're not interested. So we move on to 5. So we'll put a 5 here. And 5 times what is going to give us 25? Well, that's actually 5 squared, so it's going to be 5 times 5 gives us 25. And 5 is prime, so we've got this 5 here, we've got both of those 5s there are prime, and then this 3, we bring that down, that's also prime. So here are our prime factors for 75. Now lastly, we want to do the factor tree for 210. So this one, we're lucky, we got that it ends in a 0, so our first split for this, our first branching off for this factor tree, means we can put a 2 here, because it's an even number. Now, 2 times what will give us 210? Basically, we're asking 210 divided by 2 gives us what number? And we get that that's going to be 105, right there. Now, 105 is not prime, and it's not divisible by 2, but if you add the digits, you get 1 plus 0 plus 5 is equal to 6. And 6 is divisible by 3, which means that 105 is also divisible by 3. So we can break this down, and we get 3 times something. Right now, if you wanted, you could do long division. You could do 105 divided by 3, and then figure that out. And if I quickly do it down here, 3 doesn't go into 1, it goes into 10. 3 times, we're going to subtract 9. We're going to have a 1 and a 5. 3 is going to go into 15 5 times, and we'd subtract that 15, and we would get a 0, which I'm running out of room for. So that gives us, you can do that quick long division, it's going to give you that we get 35 right here, or maybe you can just sort of guess and check, or maybe you just know it, that 35 times 3 is going to be 105. But if not, then you can always do that long division. And while I am erasing it here, that's only because I have limited space. If you're writing a test and if you aren't squishing it into the corner, leave the work that you show, leave it on the page. It's always good. In case you've made a mistake somewhere, at least whoever's looking at it later can see where you might have gone wrong. Alright, now with this 35, we can break this up one more time. It's not divisible by 2, it's not divisible by 3, but it is divisible by 5. So we can put a 5 here. 5 times what is going to give us 35? If you practice your timetables, you get that 5 times 7 gives you 35. Right? And then we're just going to sneak, hang on, I'm going to move that 5 a little bit. So we got that 7, we got that 5 right there. And I'm just going to sneak this 3 down here. And I'm going to sneak that 2 down there. Just so that we have all those prime factors in a line. Right, so we've got 2, 3, 5, and 7 as the prime factors that you can multiply all together to get 210. Alright, so now we have the prime factors for 45, we have the prime factors for 75, we have the prime factors for 210. So we can just list those, or if you've got them in this setup and you've circled them, then you could just look at the ones that you have. I've gotten in the habit of listing them, so we're going to list them. I'm going to get rid of that title. We know the numbers that we're dealing with here. So we get that 45 is equal to 3 times 3 times 5. 3 times 3 times 5. We get that 75 is equal to 3 times 5 times 5. And for 210, if I can box that there, then we get 210 is equal to 2 times 3 times 5 times 7. So that gives us everything that we need, right? This has all of the prime factors for 45, for 75, for 210. So for HCF, we've done the factors part. All of this was just getting the factors part. Now we want the common factors. Well, here we've got for 45, 75, and 210, they all have a 3, right? We've got a 3 here, we've got a 3 here, we've got a 3 here. This 2 that we've got kicking about down here isn't common anywhere there, so we don't have to worry about that. That 7 also isn't going to help us, but we do have a 5 in common, right? We got a 5 here, we got a 5 over here, we got a 5 over there, right? Now we do have an extra 5 here, but because we don't have a second 5 in the other lines, that one's not a common factor. We've got 2 5s here, but only one of them in each of the other lines, so we can only use one of those 5s. And if you preferred, you don't have to circle them individually. If that's getting kind of complicated, then I mean, if you line the numbers up a little bit better than how I've lined them up right now, you could have done that bubble thing that we were doing when we were working with groups of 2 numbers. So you can bubble together those 3s like that, and then we can bubble together the 5s in the same way. For now, just to be consistent, you can bubble those in like that. So we've got those 3s and those 5s. So now we've found the common factors, right? No, we haven't found all of the common factors, but this is sort of, we've found that this 3 is common, that 5 is common, and if you sort of extended this idea a little bit, you get, 1 is a common factor of all of them, 3 is a common factor, 5 is a common factor, but so is the product of these two numbers, right? 3 times 5 is also going to be a common factor. And for your HCF, you're just going to take this one and that one. So we've got a 3 from this first bubble and a 5 from that second bubble. And we multiply those together, and that's going to give us 15, which is our highest common factor right there. For this particular example, our highest common factor is 15. Alright, hopefully that's making sense. So basically you just take whatever you have in common and you put a bubble around them, and then you put a bubble around anything else that you have in common, and whatever number is being represented in each of those bubbles, you multiply those together. So we had 3's being represented by this bubble here, 5's in that bubble over there, so we multiply those together and we get 15. Cool. Now we're going to do the same problem, HCF of 45, 75, and 210, the other way, with that division method. So I'll leave these numbers here. I'll get rid of everything below our actual starting numbers. So we'll get rid of the factor trees, we'll just keep those 3 numbers there because it's already set up for the division thing. And I'll leave this bit at the top so we can sort of refer back to it, right? We got our HCF was 15 using the first method. Let's see if we get the same thing using the second method. So if we start with this 45, we put that L-shaped thing, well, we're going to put that L-shaped thing around all of them, and that L-shaped thing is representing division, right? So this is our division method now. So we look at this 45 and we ask ourselves, what's the smallest prime number that we can divide 45 by? It's not even, so it's not going to be 2. But we know, maybe from earlier, or you've done that addition trick of adding the digits together, you'll find that it is divisible by 3. 45 divided by 3 is going to give us 15. Put another one. We're going to keep doing this until we get a 1 at the bottom. 15, it's not even, so we can't use 2, but we can use 3 again. 15 divided by 3 is going to give us 5. And then 5 is divisible by 5, and that's going to leave us with a 1 at the bottom. So we're done there. Similar idea with the 75. It's not even, so we can't use the 2, but we can use 3. And if you're not sure, you do that addition of the digits trick. 75 divided by 3 is going to give us 25. So we put another L-shaped thing there. Now we want to do 25 divided by something. It's not even, so we can't do 25 divided by 2. 25 is also not divisible by 3. If you add the digits, 2 plus 5 equals 7. That's not going to work. 7 is not divisible by 3, so 25 isn't either. However, it ends in a 5, so it is divisible by 5, the next prime number. 25 divided by 5 is going to leave us with 5. And then we put one last L-shaped thing there. And 5 is a prime number, we're going to divide it by itself. 5 divided by 5 is equal to 1. Once you get a 1 down there, you're done for the time being. Now we do the same thing with this 210. It's an even number, like we were getting before. 210 is an even number, so we divide that by 2, and that's going to leave us with 105. And just to save you some time, since we've already calculated this one once, we know this is divisible by 3. If you could add the digits, you'll see that it's divisible by 3. 105 divided by 3 is going to give us 35, as we were getting earlier. Now 35 isn't divisible by 2 or by 3, but it's divisible by 5, so we can put that there. And we'll get 35 divided by 5 gives us 7, and 7 is a prime number, so we'll put a 7 here. 7 divided by 7 is 1. Now we get, once again, so we're going to say 45 is equal to, and we're just going to take these numbers here in this column and multiply those together and put that here. So we got 45 is equal to 3 times 3 times 5. We got 75 is equal to 3 times 5 times 5. And we got 210 is equal to, all of those multiplied together, we got 2 times 3 times 5 times 7. Right, so we got 2 times 3 is 6, 6 times 5 is 30, 30 times 7 is 210. You can always do that check to make sure that you're on the right track. And so from there, we just got to find what we have in common. Well, we got a 3 in common, right, so we can put that bubble around those. And we got these 5s in common. I'll put the bubble there slightly differently this time, so it's a little bit straighter. And we're just going to multiply those together. So we got a 3 that's grouped together in this bubble, multiplied by, we've got 5s grouped together in that bubble, so I put a 5 there. And our highest common factor is 15, which matches what we were getting before. Alright, so hopefully this is beginning to make a little bit more sense now. And you'll see that even though we're working with some bigger numbers and we're working with more numbers than we were before, it's not actually that much harder. Or at least hopefully it's not that much harder. It's longer, and maybe it takes more time to work out things like, 105 divided by 3. We're not working with smaller numbers now, so it does take a little bit of work, but it's the process. Once you do it with two smallish numbers, it's the same process, you're just working with bigger numbers. The division gets a little bit harder, the multiplication gets a little bit harder when you're double checking your answer. You might have lots of common factors, you might not have very many at all. You might have big numbers as your common factors, like 17s or 23s or something as your prime factors. So there are ways that it's different when you're working with bigger numbers, but it's not really that different from working with smaller numbers. It's just a little bit longer and the numbers are a little bit bigger, but from our multiplication and division, we are capable of handling those bigger numbers as well. Right, so my goal was actually to get through 2 more of these examples in this lesson, solving them both ways. So I'm going to do this next one a little bit faster. So we're going to do, this time we're going to do the HCF of, and we're going to do 72, 124, and 164. Alright, so this could give us a big number, because we're dealing with some fairly large numbers here. Or it could give us a small number. Maybe, you know, you have a number like 12 or 16 that might fit into one of these, but it doesn't quite fit into the others, so we have to just throw it out. It's not going to be our common factor. You could have really small numbers. It could be 2, could be 4, could be 8. Even though we're working with such big numbers, your HCF could be a fairly small number. So let's go through it. We'll start off with the prime factorization. So we'll build our, I'm going to put, is, right? HCF of those three numbers is, and whatever we get as our answer for prime factorization, I'll put over there so that we can check it when we do the second method. So I'm going to put the 72 here, 124 there, 164 there, and we're going to work through it. So we'll start with this 72. We're going to break it up. It's an even number, so we can put 2 times, and I'm going to just save you the trouble for now. 2 times what gives us 72? It's going to be 2 times 36. 36 is not prime, so we break that up. Still an even number, so we can put a 2 there. 2 times what is going to give us 36? It's going to be 2 times 18, which gives us 36. We can break that up. 18 is still even, and that's going to be 2 times 9. 2 times 9 is going to give us 18. And then 9, finally, can be broken down into 3 times 3, right? It's not divisible by 2 anymore, but we can just move on to 3. And I'm going to pull these other numbers down. We've got 2 times 2 times 2 times 3 times 3 gives us 72. And if you wanted to double check that, 3 times 3, whoops, not sure if you can see that. Down here we've got 2 times 2 times 2 times 3 times 3. So we've got 3 times 3 is 9, 2 times 2 times 2 is 8, 9 times 8, 72. So we can be confident that we've done that one correctly so far. So now we'll do the same thing for 124. Right? And actually I'll put that oval around this down here. So there we go. Now for 124, that's even, so we can put a 2 here. And that's going to be 2 times. And so if we wanted to do long division, we could. This should give us 62, I believe, if I've done this right. 2 times 62, yes, that should work. And you can always double check if you're not sure. Just do the multiplication and check. 2 times 2 is 4, 2 times 6 is 12, that's 124, and we're good. Now 62 is not a prime, so we can break that up, and it's still even, so we can break it up into 2 times something, and we're going to get that it's 2 times 31. Now the neat thing here is, even though we're dealing with a number that, you know, it doesn't look like it's particularly unfriendly. It looks like the number that at first glance people might be like, oh, you know, it's divisible by so many things. It's you know, we know 24 is divisible by 3, so maybe 124 is divisible by 3. But then when you do the trick, you find out that it doesn't quite work that way, and it's not divisible by 3. And so you're left with, when you get your prime factors, you don't have any 3's whatsoever. You've got 2 times 2 times 31, and 31 actually is prime. So even though this number looks like it's not far off from 128, which would be much longer when you're writing it out with prime factors, the prime factorization for 124 leaves you with only 3 terms, 2, 2, and 31. And if you wanted to go through that, we know 2 times 2 is 4, so we're going to do 31 times 4. 4 times 1 is 4, 4 times 3 is 12. Yep, that returns the 124 that we started with. So, there are our prime factors for 124. Now for 164, we'll do the same thing. It's even, so we break that up into 2 times something. And I'll save you the trouble of working through that. It's going to give you 2 times 82. 82 is not prime, it's divisible by 2. So we break that up, and it's going to be broken up into 2 times. And it's actually going to be 2 times 41, which, for those of you who have caught on for this particular example, 41 is also prime. So we bring this 2 down, and we're finished. So we've got our prime factors. For 72, it's 2 times 2 times 2 times 3 times 3. Pretty long, even though it's our smallest number. And then our bigger numbers, for their prime factorization, it's pretty short. 2 times 2 times 31 gives us 124, and 2 times 2 times 41 gives us 164. So, if we want to list all of those, we get 72 equals 2 times 2 times 2 times 3 times 3, right? 124 is equal to 2 times 2 times 31, and 164 is equal to 2 times 2 times 41. And now we just need to group together whatever we see that's common. This 41 and 31, we're not going to have any luck with that, but we do have 2's in common here and right here, but that extra 2 isn't any good for us because we need a third 2 in both of these second and third lines in order to be able to use that extra 2 up top. So our highest common factor is just going to be, well, we've got a 2 represented by this bubble over here, so it's going to be 2. Whoop, I don't know if you can see that up there. We got that 2 up there, times, well, the thing represented in the other bubble is another 2. So it's going to be 2 times 2, which is 4. Just 4. Nothing particularly special. You know, you might have expected it to be a little bit larger than 4, even if it was something like 8. We know 8's going to go into this, but if you go through the math, you could do 124 divided by 8. You can always try it, right? 8 goes into 12 once, minus 8, it's going to leave you with 44. 8's not going to divide cleanly into 44, so we're going to have a remainder or a decimal. It doesn't work, even though those numbers all kind of maybe look at first glance like, oh, you know, maybe they should be divisible by 6 or 8 or something like that. Turns out they're not. It doesn't quite work that way. Some of them might be, but they need to all be divisible by that same factor, which is the key, right? You might have much, much larger factors, right? For example, 82 is a factor of 164, but when you're considering it alongside 124 and 72, we've got to throw that 82 out the window because we're looking for common factors, and then the largest common factor, the highest common factor. And so in this case, that's only going to be 4. So in this example, you can see that even though you can be working with some larger numbers, the highest common factor might still be a fairly small number. Alright, so I'm going to get rid of these factor trees, and unfortunately I don't think we're going to get through this example and the next one in this video, but perhaps when we do our test review, I can quickly go through that last highest common factor example, and then we'll break down the lowest common multiple and highest common factor things you should know before your test. But we'll finish this one, we'll do this one the division way, and then we will wrap this one up with that. So we'll start with this 72. It's even, so we can divide this by 2. So we can do 72 divided by 2, that's going to give us 36, which is still even, so we can divide that by 2 again. 36 divided by 2 is going to give us 18. That's still even, so we can divide that by 2 one more time. 18 divided by 2 is going to leave us with 9. Now 9 is not divisible by 2, so we move on to the next prime number, so we get 3. 9 divided by 3 is equal to 3. And then 3 divided by 3 finally gives us 1 down there. Alright, hopefully you're beginning to get how this works. 124, same idea. It's even, we divide it by the smallest prime number we can find, and because it's even, we're going to take advantage of that fact and divide it by 2. 124 divided by 2 is going to give us 62. 62 divided by the smallest prime number we can find, it's even, so once again we take advantage of that, we divide it by 2, and that's going to leave us with 31 down here. 62 divided by 2 gives us 31. And then you have to be observant enough to realize that 31 is indeed a prime number. And so there, you just divide this by 31, and you get a 1 down there. Alright, now even when I was going through this, I was like, really? I only divided by 2 a couple of times, and I'm getting a massive prime number left over. So if you're in doubt, when you're going through practice problems or anything like that, unfortunately I haven't made any highest common factor practice problems yet, but I'll see if I can find a little bit of time to do that and then send those your way. But if you Google highest common factor practice problems and you just want to find the highest common factor for some of these, you might find yourself dealing with some really, really big prime numbers, and in turn getting some really, really small HCF values, because those prime numbers just aren't common with everything else. But we're jumping ahead right now. Let's finish off with this 164 over here on the right. 164 is even. We take advantage of that. We divide it by 2. That's going to leave us with 82, which is even again. So we're going to take advantage of that. Divide it by 2. We get 41. If you're comfortable with your primes between 0 and 50, I know I said we won't see very much over numbers like 17 and 23 and stuff like that, but I'll try and make sure that you won't come across numbers quite like these on your test for being able to recognize if they're prime. But it's good to see them every now and again, that numbers like 31 and 41, it's good to be reminded now and again that they are indeed prime numbers. And so then 41 is going to be divisible by only 1 and 41, so we do that. 41 divided by 41 leaves us with 1 at the bottom, and we're just about finished. We just go through one last time. We write 72 equals product of all of those, 2 times 2 times 2 times 3 times 3. 124 is equal to 2 times 2 times 31, and 164 is equal to 2 times 2 times 41. And then from there we want to figure out what we have in common. So we just put a bubble around whatever's in common in all 3 of those lines. We get 2 is common here, and 2 is common here, but unfortunately that third 2 has to sit out for this one because we don't have enough 2's in the other lines to pair up with it, right, to make that group that we can put a bubble around. So we get our highest common factor. We got a 2 is represented by this bubble, and a 2 is represented by that bubble, so our highest common factor is just going to be 2 times 2, which, as we got before, as we were getting before, is just 4. Right, so hopefully this whole idea is making sense. Once again, on the test, once you guys are getting closer to that, I'm going to have to see how we're doing with scheduling before I just blindly make another test for you. But on the off chance that you guys are behind by a video or 2, then maybe I'll just throw out an extra video for practice problems. Put that out there and send that your way so that you guys can do a little bit more practice, maybe of this and lowest common multiple, or I can make the test review a little bit more extensive than last time. But yeah, hopefully this idea is making more sense. On the test, for lowest common multiple and highest common factor, you'll be asked to do both. You'll have some questions for LCM, some questions for HCF. Use whatever method is most comfortable, because I don't want to be sitting here and telling you you must solve it this way and only this way, because if I was going to do that, there's no point in me showing you 2 or 3 different methods, right? I showed you one method that doesn't really work that well. It doesn't work all the time. I mean, it works, but it's slow, right? It would be like saying calculate 2 times 200, and you just sit there and you go 2 plus 2 plus 2 plus 2 200 times. Like it works, but it's really slow, right? So when you're doing that for highest common factor and least common multiple, use whatever method you're most comfortable with. If you like prime factorization, use prime factorization. If you like the division thing, use the division thing. You have these options available to you, and then if you like that list method for smaller numbers for HCF, go ahead and use it. If you like, just writing out the multiples when we were doing that for lowest common multiple and then just figuring out which one they have in common, go for it. You're allowed to use whatever method is most comfortable for you. Just try and make sure you're good with at least one of them, and preferably one of these two, because they work more often than that listing method that we've been doing as sort of the third method, that I introduce it so you can see kind of how it works, but then we throw it out because it doesn't work for bigger numbers. Alright, so I will put out another video for sure regarding this stuff, at least as a test review, and possibly another one of practice problems once I sort of sync up where we're at with scheduling for this, before you guys get another quiz. I know this one, this quiz is coming up sort of like really soon after the last test you guys had. Not all of our units are going to be this way. This was just sort of like a little mini topic, so there's a little quiz coming up at the end of it, and that's why it's coming up sooner, or that's why it's coming up so soon after your last quiz or your last test. We'll have more time to sort of digest our next topic, which I believe we're moving on to fractions and decimals after this, but we'll have more time to sort of digest that topic as we go through the unit, and you'll have a little bit more of a breather between this test and that test when we get there. So if you guys have any questions, get in touch with me, and as always, I will see you in the next one.